Hey guys, so in this lesson we're going to tackle some more challenging problems dealing with investing and borrowing money. So these are compounding interest problems. We've done a little bit of this. If we read the text in this first one here, we'll see what we're changing up. So our guy Jaden is investing $65,000 in an account paying an interest rate of 2.1%, compounded quarterly. So I'm actually going to highlight that. Compounded quarterly is the change. So compounding means how often the interest is added in. So I'm going to call it a compounding period. So a compounding period is how often interest is applied. So we've been dealing with examples where it's applied every year. And then in that last lesson where we learned about the number E, we learned about them compounding the interest constantly. Here we're going to look at all the cases in between. The model is going to be pretty much the same. We'll use y equals a times 1 plus r t, like that. So this was our general model for interest, right? Where 1 plus r is like our b, r is our interest rate. Now, to account for the compounding period, we're going to turn this model into something just a little bit more complicated. So it'll be y equals a times 1 plus r over n times nt. Okay, n is the number of compounding periods. So what that means is if we are compounding quarterly, quarterly means 4 times per year. To change our general model to a quarterly model, we'd make n equal to 4 in both cases. And that kind of makes sense, right? So this exponent grows 4 times as fast, so instead of t, it's 4t, right? And then we divide that rate into the 4 periods that we're applying it. Okay, so let's see what this looks like. This is just kind of plugging it in and chugging along. So Jaden's investing $65,000. It's a lot of money, Jaden. And then 1 plus r, so my interest rate, we're going to write it as a decimal, so 0.021 over 4 is my compounding period, quarterly, to the 4t. Okay, then I just plug everything in. So I'm looking for 7 years, so I plug in 7 to my time, and that's it. Then I just type it into my calculator just like I see it. So 4 times 7 up here I'd have. And I would do, you can use your fraction key for this, or you can do parentheses here. And then I would do parentheses around this whole thing up here for the exponent, and you should get the correct result. I got $75,260 he makes in 7 years. So the rich get richer here. I actually should say that I got, on my calculator, I got $75,264.06, and then some more decimal business over here. And then by rounding, I got this. So we're not confused, because it says rounded to the nearest 10 bucks. Okay, so before you move on, make sure you can type this into your calculator. So this expression here with the parentheses and the exponents to get this. So make sure you know how to type it in correctly, and make sure you understand the problem from top to bottom. Okay, so we're always going to be using this formula on these problems here. So here is absolutely must capture this before you tackle the practice. When you're ready, we're going to move on to another example where we compound daily. Okay, so here, if you read the text, we have the exact same problem. So I didn't change any of the numbers, except for instead of compounding quarterly, we're going to compound daily, right? So we're still going to use that same formula, A times 1 plus R over N to the NT. And then our rate is here. We're investing $65,000, still rounding to the nearest $10, and we're still leaving the money alone for 7 years. Okay, so our setup's going to look exactly the same as the last problem, except for our n. So our n in this case, if we're compounding daily, well, there's 365 days in a year. And then our r, I'll write for good measure, 0.021 from 2.1%. And then just set up the exact same. Okay, so here we see the setup for daily. Remember, quarterly, it was a 4 instead of 365, right? So we see like this exponent grows a lot faster in this case, and that makes sense, right? Because we're compounding the interest every single day instead of just once a quarter. Okay, so again, we just plug it in our calculator as we see it pretty much, and then parentheses around my fraction and a parentheses around my exponent. Oh, I got to plug in 7 here, don't I? So I'll rewrite it with our 7 plugged in. Okay, so that's what we should type in, and you should get 75,292.68 blah 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 blah. Remember, we're rounding to the nearest $10, so really my rounded solution is going to be $75,290. Okay, so there's my result compounded daily. Okay, so remember, we started with the same amount of money, but just added in more interest more often. So if you recall, in our first example, we ended up with $250, $75,250. Here we ended up with $290. So not that much when you're talking about 65 in the grand in the bank over 7 years. But notice this is higher, right? So the more often you compound, more dollars you make. Or owe if you're talking about loans. So this relates back to our payday loan example, right? Okay. If you're doing this lesson, you're probably more than ready for it. As always, reach out if you have any problems.